In this video, we're going to talk about how to predict the future. Now, in math classes, they call this finding the equation for a tangent line, but it really amounts to the same thing. Suppose you're driving down the road at 60 miles an hour. Where are you going to be a minute from now? Well, common sense is that you're going to keep going 60 miles an hour, and that you'll just be 1 mile down the road. Where are you going to be 2 minutes from now? 2 miles down the road. Now, this isn't exact. You might speed up, you might slow down, you might hit a traffic jam, you might get into a drag race, but it's a pretty good prediction. Likewise, if you have any curve and you know the history up to right now, and you say, hey, what's going to happen next? A pretty sensible prediction is to say, hey, let's see, which way are we heading? We're heading in the direction of this tangent line. So right now we're heading in that direction, and we'll just draw the tangent line, and that's going to be our prediction for the future. We're changing at a certain rate. Let's just assume that we keep changing at the same rate forever. Now, this isn't exact. It doesn't take into account the fact that the curve will curve. It won't go in a straight line. It might curve up, it might curve down. We don't really know, but it's going to be a pretty good prediction for a while. It'll eventually fail, but it's a good prediction for a while. And if you wanted to know where you were a little while ago, tracking the tangent line backwards is a pretty good estimate of where you were a while ago. Where were you a minute ago? Probably about 1 minute back along the road. Where were you 2 minutes ago? 2 miles back along the road. Okay. So it's really useful to find equations for tangent lines, because by looking along the tangent line, you can make really good predictions about the future. You can make really good estimates about the past. Now we're going to get into much more detail about those estimates when we get to the section on differentials, but not yet, not today. So here's a problem. Find the line tangent to the curve s of t equals 4t squared plus 3 at t equals 2. In other words, if you aren't good at algebra and aren't good at squaring stuff, give me a straight line formula that will tell me approximately where we are at time 2.1 or 2.2 or 1.9 or 1.8. It's going to be good as long as t is close to 2. So there are several steps. The first step is find the slope. And how do you find the slope of a tangent line? Well, that's what we did in the last video. We take the limit of the slope of the secant line. If you take s of t minus s of 2 divided by t minus 2, that's the average rate of change. And then you take a limit as t approaches 2. It's a slightly complicated problem. If you are new to this, go look at my previous video where we worked this problem, and the answer is 16. Notice that the answer is a number, not a function. Some of you might be saying, oh, I know a formula for the derivative. The derivative of 4t squared plus 3 is 8t. That's fine after you plug in t equals 2 to get 16. A line is something with a constant slope. The slope is a number, not a function. Second is you find out where the point of contact is. Well, at t equals 2, s equals 19. So we're looking at the point 2, 19. So t equals 2 and s is 19. And then you use your good old point slope formula for a line. Now usually you call the input x and the output y, in which case the line is y minus the starting value of y is the slope times x minus the starting value of x. Here it's going to be s minus the starting value of s, that's s minus 19, is the slope times t minus the starting value of t. So in point slope form, our tangent line is s minus 19 equals 16 t minus 2. And then if you want, you can do a little bit of algebra to convert that into slope-intercept form, s equals 16 t minus 13. Frankly, I think that this form is actually more useful, because that's the one that you can use to get good estimates. What's going to happen when t equals 2.1? Well, when t equals 2.1, this is 0.1. 16 times 0.1 is 1.6. And s is going to be 19 plus 1.6. That's 20.6. Okay, so this line allows you to read off pretty quickly what's happening when t is close to 2. S is going to be 19 plus 16 times t minus 2. And that will give you good estimates for the future and the recent past. Okay, we'll do more details on that in a later section, but you don't need it yet.